Yes, my name is Dimitrios Athanasiou, and I'm a policy officer in the buildings team of the energy efficiency unit of DG Energy in the European Commission. Thank you very much, Giacomo, for inviting us here. It is, the timing couldn't have been better. Now, only a couple of months after the revision of the Energy Performance of Buildings Directive. So it is also very important for us to present the new elements of the directive, but also to see in place what's happening in other areas and domains and possible work on potential synergies together and see whether we can both benefit. So today I will try to briefly describe you the new elements of the revised directive and also speak a little bit about an initiative that was launched a couple of years ago, the EU Building Stock Observatory. So I'm starting. As a starting point, I would like to mention that indeed buildings remain very high at the political agenda of DG Energy. That is because buildings consume a lot of energy and it's one of the most important pollutants as well when it goes to greenhouse gas emissions. So there are many things that we can actually do with the building sector in order to contribute to our objectives to meet the energy efficiency targets and the greenhouse gas targets. Despite the progress made over the last decades, especially increasing the ambitious level of the minimum energy performance requirements, but also within the products area, the white products, and all these appliances, increased performances in the building sector. We can say that now new buildings can consume at least 50% less of buildings constructed like 30 years ago, but still the building stock is not very taking under consideration actually the renovation rates, which are very low, and also the low new construction rates, and then we can see that almost 75% of our building stock is not performing well. So there is a lot of things that can be made, and we can build on that. And of course, there are many areas that we can focus. That was the conclusions of many studies, researches, and many studies. Also the modeling. Everything has come to, all of this have come to a conclusion that building renovation rates has to be increased, and also financing has a more important role to play. But again, in this era of digitalization, smartness in buildings and also ICT technologies have a big potential to contribute. The evaluation of the energy performance of building directive being done as part of the Clean Energy for All Europeans package actually revealed that the whole architecture of the directive is working well, mostly for new buildings where the nearly zero energy buildings, future-proof vision, it's well established, and NZEBs now are mobilizing stakeholders accordingly, the whole maybe value chain. Cost optimality has also been proven to be an efficient way to set minimum energy performance requirements, while over the last 10-15 years, energy performance certificates, EPCs, has also proven to be a useful market tool. But still, the evaluation of the directive has also revealed that there are always areas that can be improved. And I'm not talking about streamlining existing provisions with future 2030 targets and such, but also simplification and better linking with financial elements, and also support for the decarbonisation of the existing building stock, and of course to modernize the directive, which is a big issue. So last summer in June, the revised directive was published. Actually, the directive amending the directive was published after a long process of negotiation and after 3 trialogues and many other steps in between. Member states will now have 20 months to actually transpose it and start implementing it. That leads to 10th of March 2020. Within this period, we plan, in the Commission, in our unit, to work closely with Member States and also other stakeholders to see how we can support them to properly transpose it and also implement it. The main outcomes of this directive, of the revision actually of the directive, is that the directive now it's more supportive towards building renovation and also financing instruments. And a second area, which is maybe more related with our conference here, is that the revised directive is now more smart by ensuring the use of ICT and modern technologies. But I will briefly go through all this in the following slides. So the first, most let's say, well-debated provision is that that renovation of buildings have to be increased, both the rate and the depthness of renovation rates. So we decided, it was decided, not we proposed, and co-legislators actually decided to move Article 4 on long-term renovation strategies that member states have to implement every 3 years, to move it from the Energy Efficiency Directive to as a new article in the Energy Performance of Building Directive, and also complemented with more elements to be considered when member states and national authorities develop these strategies. The focus is also on the implementation, so it's not only reporting, but also how to implement those strategies through public consultation platforms, and maybe by requiring member states to also have milestones for 2030, 2040, and 2050, but also measurable indicators. I will also try to make a link with the objectives, of this conference, and I can start with these long-term national strategies. That the starting point of those strategies are an overview of the national building stock. So initiatives such as INSPIRE could help actually national authorities to have like a common framework on defining this building stock, the national building stock. Another new area, thank you, Jacob. Sorry. Sorry about that. So another new area that the directive is now provides is electromobility. Electromobility actually is a policy that is provided by the Alternative Fuel Directive, which covers the public sector, but We also support this directive with the private sector, meaning infrastructure to be installed in buildings. So there are different provisions for non-residential and residential buildings requiring for new and majorly renovated buildings to either install a recharging point or prepare the whole infrastructure for a recharging point to be installed at a later stage. So there are many details, and I don't want to get into the details now, and there are many conditionalities under which all these requirements will be applied by member states and by the buildings of the future. But this is also an area where your work here in INSPIRE and in other related areas could also be explored, for example, by locating those recharging points. Another article of the directive advocates the introduction of an optional common European scheme for rating the smart readiness of a building, named Smart Readiness Indicator, the SRI. So, how, when, and how we will exactly implement this indicator will be explored in the coming years through an implementing act and through a delegated act, which will describe exactly the details of what this indicator will be and how this will be enforced and its complementarities with other schemes such as the Energy Performance Certificate and building passports and anything else. But this indicator will actually try to characterize the ability of a building to manage itself, but also to take, to interact with its occupants and the needs of the occupants. And finally, it's also about interoperating with the grids. Of course, this is an area that, again, the whole data sets that the indicator and your work can also be worked together. Together. Another area is, again, related with inspections of air conditioning and heating systems that are now updating and focusing now on larger buildings. So there is a threshold, a higher threshold up to 70 kilowatts for both heating and air conditioning systems to be inspected. The threshold was significantly lower. It was 12 and 20 kilowatts. But now the focus is on larger buildings, such as offices or big shopping malls, where inspections can actually be effective. And then there are also alternative measures to be implemented instead of actually physical inspections, such as electronic monitoring. And also there are many provisions to require, under the conditionality of technical and economic feasibility of building automation and control systems, but also self-regulating devices to be installed. Again, we have been discussing that all this smartness of buildings, it could also be an area to be explored with data sets coming from geospatial data. Towards better data, there is also some new provisions related with the energy performance certificates and their role towards financial instruments, but also it's about the energy performance certificates database and registries that member states, almost all member states, have in place. And now under the new directive, the revised provisions, those databases should also measure actual data, not only estimated data, but especially for the public sector. And also this data should be made available upon request for the building owners, but also for scientific and academic reasons. This work is very well linked with another initiative that we have taken in DG Energy, the EU Building Stock Observatory, which was actually an initiative towards the need for more and better data. So back in 2016, we have launched the EU Building Stock Observatory to provide a snapshot of energy performance of the EU building stock, but also to build on specific indicators and methodology for the continuous monitoring of the building sector. There are many, many topics covered there, starting from, indicators about the building stock, age of the building stock, numbers, and also the building sale, U values, technical building systems, number of nearly zero energy buildings, EPCs, and also energy poverty and other elements. All this resulted to a web tool that is integrated in DG Energy's website with a database, with a data mapper and some fact sheets for each member state, but also for the European Union as a whole. During the first phase of our contract service, we identified many, many data gaps and limitations. So we decided to proceed with the second phase. And the second phase is about actually revamping the web page and all the tools, but also it's about rationalization of the indicators, bridging the gap, the data gap, data validation, and so on. So we expect that the new observatory will soon be launched. I mean, the web tool will soon be launched in our web page, and it will work hopefully faster and providing all elements. And of course, the EU Building Stock Observatory is an area where we can definitely explore more synergies on how to, there are many things that we can do with data here, and we can, of course, see synergies with INSPIRE and break down, for example, of regional data or getting data from other databases. The plan is that the future, all this to be an open source. We're exploring through other contracts, big data initiatives. So yes, it's an area that we can definitely build. I'm also willing to see the presentations coming from the speakers on what exactly can be achieved and how we can merge our work. So there is also, for the reasons of completeness, a slide on smart finance for smart buildings initiative, because finance is also very important. So we have also launched this initiative in order to make more effective use of public funds and also assist the aggregation of projects and make work on de-risking through the de-risking platform that could help financiers and national authorities to get access to finance. I'm concluding with this slide on the wider benefits that NZEB and high energy performance buildings can provide, but also I would also like to highlight that we work closely with other DGs like Digit and Digit Connect, but also with JRC in finding areas on how to best combine our work and our instruments and our tools with other initiatives such as INSPIRE and other, maybe Copernicus and other data sets and databases that could contribute to our work and also could also help member states actually. So it was. There were many things that I wanted to say, but I hope I'm within the 10-15 minutes framework. Thank you. I'm happy to take any questions later. Thanks.
There? Okay. So this is what I'm going to present to you today. It's a very long title, but the main concept here is trying to link energy with location, as you are in the workshop here, but mainly focusing on EPCs and how this can be harmonized using INSPIRE. So mainly is that the main focus. A small point on Cardiff, where I come from, the technology center where I work. It's a research center, and it's also a foundation. If you want more information, you can please visit the web. We are there in Spain, in Valladolid. And there are three main divisions there. Particularly, I work in the energy division, and we focus on these 5 themes. As you can see, the first one is energy policies. That's why we are here. And we also work on smart cities, energy efficiency, renewable energy, or smart grids. So this will be the content of my presentation, because we have a really nice presentation before on the EPBD and the new aspects that have been changed in the recast. The first point will be really short. Then we will focus on 2 projects. One is the energy pilot, which is led by the GRC, where these aspects related to the harmonization of EPCs have been tackled, and an internal project that we have in Cardiff, which is called the Planner Project, where similar aspects have been also studied. Then we will see what the main achievements have been within this use case 1 in the energy pilot, which is devoted to the INSPIRE harmonization of EPC datasets, and then trying to find a link to a Spanish case study and see how this could be really applied. So before delving into the topic, all of this work, it must be mentioned that I was lucky enough to be collaborating in the GRC, and this is how this has worked. So a really short note on the legislative aspects to bear in mind. We have had this presentation on the EPBD, which is the main one related to energy and energy performance certificates, EPCs. And we are trying to bring all this in relation to the INSPIRE directive. As you can see in the image there, they cover different scales. So it's really interesting to link it to INSPIRE. Now, the 2 projects I mentioned before. We have the energy pilot on one side, which is a really wide project that has, as you can see, 6 different parts, which are called use cases. In this presentation, the most interesting one is the first one, since it deals with the INSPIRE harmonization of existing energy performance certificates. And in the other part, we have the Planner Internal Cardiff project, where we try to develop a platform for decision support making for energy planning. And we had 2 ways to do so. First, we could, I don't know if I can, I don't know how to. In the first part, you can see that we try to support energy planners by trying to locate the EPCs and map them, and you reference them so that you have a map where you can see which areas are most in need of a renovation. And on the other hand, we also provided an estimated value. So what we did is trying to take data from the cadastre. In the case of the Spanish cadastre, is harmonized to INSPIRE, so it's really good to work with. Then we automatize the tools that we have in Spain, and we estimated the EPCs, we calculated the demand, and we mapped it. So, as you can see, the main link within these two projects and what I'm presenting here are the things highlighted in yellow. With respect to the GRC project, the use case 1, the main objectives you can see in screen. It was to establish an accessible and interoperable common knowledge base for EPC datasets to support local government and private sector involved in energy efficiency policies. So, to do so, one of the main achievements was to try to take a region. In this case, it was the Trento region in Italy, and the EPC datasets, the structure, was analyzed based on real EPCs, and a target data model was created based on INSPIRE, so that it could be replicated elsewhere. And that is exactly what the collaboration with Directive was based on, to try to take this target data model generated based on the Italian region and try to replicate it in Spain. See if that is possible, if that matches what we understand in Spain for an EPC, or what difference were there, and so on. So this is the target data model. Sorry. It was built on the theme buildings and created an extension. So here you can see the buildings, and in the yellow you can see the extension, and you can see 5 feature types. It's based on the certifier, certificate, professional, energy system, and energy conversion system. If you want to see these in more detail, please visit the web below. So, for the Spanish case study, what we did, we wanted to find a data model for the planner project that we had, based on the EPCs, and that could support the estimation of energy demand that we envisage for our platform. So that is what we look for. On one hand, we have at national level, an EPC data model defined in XML, so that it contained this amount of data. On the other hand, we have what we needed to actually carry out the calculations for the energy demand in our platform. Then a very important source, as I mentioned before, is the cadastre, which is harmonized according to INSPIRE. And our data model envisages to cover all this, like you see in the purple part. So the methodology followed here in the Spanish case study followed these several steps. I'm going to skip really fast through the submission of the EPCs in Spain so that you understand a little bit how it works, and then explain a little bit the comparison between the target data model generated in the GRC project and how it was different from the Spanish one. So the EPC submission in Spain, it has like 3 main stages. At European level, we have the EPBD, as was mentioned before. There is a framework there is a calculation method, and there are some standards to follow. Now under the mandate, sorry, for 80. Then these calculation methods are transposed in each country. In this case, in Spain, there are 5 validated EPC tools. There's one new included this year. And with them, we can issue the EPC and obtain the energy label. Finally, in Spain at least, we have a regional level where the registers are managed. So each region decides if they want to have a register or not, and what type of data are made open to the public. So, but it's important to mention that at national level is where the main format is designed, the scheme. So we have a PDF format, what is shown in paper to the public, and the XML format, which is coming from the tools, and it's very rich in data. You can see a small excerpt of this. In the PDF format, it's just 6 pages. I don't know if you're familiar with EPCs, but you have information, a little bit of information of the of the building itself and how it performs on different aspects like heating, cooling, and so on. And in the XML format, you only see here like a really small screenshot, but it's really huge. To see it like in an image, you can see here that the data sets in the XML format are really big, like 2 times what it's presented in the PDF. And from them, you can see also shaded in a different color those data that are optional and those which are mandatory. So you can have an idea of how many there are. Then it comes to the point where we wanted to compare it to the target data model generated in the GRC. We have it here, the main categories, and here we have the one used in Trento. So here everything matches, since this was used as a base to generate this. But then when we started to compare the main categories in the Spanish EPC data model, the XML version, you can see that there are many lost ends here. Then this process was not in the main categories part, but attribute per attribute. So taking the Trento data model, the target data model, comparing. I'm going to skip this fast. And when comparing these two models, the Spanish data model and the target data model generated in the GRC, here are the main conclusions. So you can see that there is the double of attributes in the Spanish data model, 254 versus 113. Well, the categories and subcategories vary more or less. But it's interesting to see that, for example, the mandatory and the optional attributes are more or less the same in proportion. So, but when we try to see if the attributes were reflected the same way in one data model with respect to the other, we saw that the one-to-one match was only found in 13 cases. So like a really low percentage. There are also other cases where we saw 1 to more relationships, where one attribute in one case matched several attributes in the other. So there's quite a percentage here of data. But there were a lot of non-matching attributes, like 199 versus 33. So the perfect matching was difficult in any case. It was difficult to obtain. There were also mismatches in terminology. The different ways to convey a same concept or similar concept was not the same. Maybe sometimes it changed in the unit, sometimes it changed in different ways. I mean, one-to-one matching was not possible many times. And there were, as I said, non-matching attributes, a lot of them. It is important to highlight, in order to understand these numbers, that whereas the XML data model in Spain contains the input and the output data, the Trento data model only contains the output data. What does this mean? That with an EPC, a complete XML of the Spanish data model, we can recalculate the EPC. We have all the necessary data. In the case of the Trento data model, there are data that is missing, so we cannot calculate again the demand or the consumption. So that is the main difference. So to conclude, we see that the EPC is like the main element within the EPBD, the main tool to convey energy in buildings, and it should not be subestimated. if we link this EPC and its power with INSPIRE, we can achieve great things. And now with the new revision of the EPBD, I think that it's a really nice moment to try to find a new version of EPCs which can be more harmonized so that it can be more comparable among countries and more reliable in the end. So as you can see also, to cover the rest of the points, the replication is possible, like in Spain. It was possible to do another data model, but the main differences were in the conceptualization of the EPCs. If you try to cover too many aspects in one country, like in Spain, whereas in others less, then they cannot be easily compared. So that would be it for me. I don't know if you have any questions. Oh.
I try to speed up a little bit with time. So the main idea is, as mentioned before, assessing energy performance of buildings. And in our case, we thought the building itself needs energy because you want to heat it, so it strongly depends on the volume. But if you do everything on a footprint, you don't have the volume. And in parallel, we have the strong development of 3D city models, where you have the volume, you have much more precise geometric representation of the building. So we are trying to combine this. And the link to INSPIRE is that with the Annex 3, there's also the 3D extension of the building model as well. So that is what we have in mind. Once we receive the INSPIRE 3D building model, can we use it for calculation of the energy performance of a building? So that is the don't see the slides here on the screen. So that is the main idea. This program already was announced, so we are use case 2 in the presentation from Spain. So that is, I don't see slides here. Okay, but it's not so important. So that is the main aim of the experiment, put it this way. We want to do analysis of different methods on energy performance labeling of buildings in the Netherlands and Germany. And they try to have in mind that this could be a methodology that can be applied in any member state country. And then, of course, you already mentioned financials have an impact as well, so it's also an cost and benefits analysis in the end. So this is a methodology for the Dutch energy performance label calculation. There are 2 different types of labels. One is a provisional energy label that is computed for every building in the Netherlands, but with a very simplified method. And then there is a certificate. So the first one is called a label, and the second one is a real certificate where you can, based on a web tool, say, refine the data set and calculate the label. There's no inspection of the building in this case. So that is, I would say, a fundamental difference from the German approach. There is someone is going to visit the building and is issuing the label, and this person needs to have a certificate as well. So not everyone is allowed to do that. So you need to have a specialist to issue this energy label or Energieausweis in Germany. And there are similar regulations when it is necessary and when it's not necessary to issue this label. So very different approach in the end, which does not simplify things. And what I just said, on the other hand, we have a 3D city model in Germany available for every building, and the main idea is shown here. We take this 3D model, calculate the energy demand, and based on this energy demand calculation, we issue a calculated energy certificate. So in Germany, it will not be a certificate because we are not the energy people issuing this certificate, but it's more comparable to the label from the Netherlands. Yeah, but we can calculate this based on data without inspection of the building itself, and we follow the DIN norm to calculate the monthly energy balance. Basically, the calculation process is very similar to what the experts doing when they visit the building. That is our methodology. So we have the 3D model, some building attributes. We do validation, things like that. In the end, on the right side, we do a physical-based simulation on the monthly energy balance. So basically, we get irradiance, shadow calculation, things like that, and heat losses of a building itself. And on the other hand, you see the building typology that we are using to fill gaps in the data set. And we have a lot of gaps, unfortunately. And we use tabular because tabular, we thought, okay, it's a European building typology, so every member state, we hoped, use it. Yeah, the CityGML model looks like this. We use LOD1 and LOD2. I skip this one. This is important. That is the main driver behind it. We have these models on different levels, the municipality level, detailed model on state level, an abstract representation in LOD2, but still roof structure is correct. And this is in Germany collected on state level and say aggregated or say report to a national level, and this will be later reported to Europe in the INSPIRE Directive in this building. Next, Giacomo will give details later. Now, how is this data, this energy label calculated in the Netherlands? And here, that's one of the challenges. Yeah, it's a very simple table in the end. Yeah? You have dwelling type and you have construction, and then you issue labels. Very simple approach. But the dwelling type is unfortunately not the tabular building typology, but it's the building typology from the Dutch Kataster. So this is the data we have, not the data model we should have. Yeah? And that's a fundamental difference, and that is very difficult to compare the results because we talk about different types of buildings in this sense. Yeah? Separate is in building typology, it's one category. The other three is, again, one category in the building typology. And we have large multifamily houses, for example, in building typology that is not represented here at all. So we really have an issue with data harmonization in the sense of which data has been collected in the past, yeah, which is really available, not so much the data model itself. Okay, and more information on this. And in the Netherlands, we choose as a use case Zwolle, where we have a 3D model from Dutch Kataster as well. In Germany, we've chosen the city of Essen as a test case. Why city of Essen and not Stuttgart, for example? Because the state of North Rhine-Westphalia has open data, so it's easier to share this data. The city model, 10 million buildings as a 3D model in LOD2 is available and shared as open data, so everyone can make use of it. In Baden-Württemberg, unfortunately, it's not so easy to share the data. That's why we choose the city of Essen as a use case. And then we compared the different approaches to generate the different certificates. So this is the Zwolle test data set. Yeah, we had to do some changes in the model because of missing attributes mainly. And for our methodology, we need year of construction as a minimum input and the usage of the building, so the building function. And we selected the center of the city here to do the calculations. And we have the similar exercise in the city of Essen. And yeah, this is the comparison of the labels calculated or by this table I've shown before and our simulation results. So this does not say too much because it's not really, visually not really comparable. So we did some analysis in more detail and compared basically the numbers. Yeah? And you see a difference, but a similar trend. Yeah? One difference is in the Netherlands, you have less categories on this certificate than in Germany. Yeah? So that makes it difficult to compare. Yeah? Not so clear. That's one thing we faced. Yeah? Then, of course, it depends on the geometric input, yeah, because you change the volume and the roof structure or the heated roof or non-heated roof. In LOD1, you can't say this because you don't know what part is the roof. In LOD2, you can say it. So in LOD2, we get a little more details on the results. Oh, sorry. Yeah. And so that is this is how the results look like. Yeah, we basically calculate the consumption per square meter per year, and in LOD1 and LOD2, and there's usually a little difference, and then we normalize this according to the heated area. Why the heated area? I don't like it too much, but it's in the norm. Heated volume would make much more sense to me, or facade area to air, because that is where you lost heat, not to your neighbor's building. But the norm says per square meter, so we do per square meter. So it's an easy calculation, but has a lot of uncertainty as well. So here, again, the comparison between the model and the real consumption. Again, it's a little bit difficult to compare this because the consumption is usually not measured per building, but per building unit. And it was not so easy to say these building units belong to this building. So here also, you can compare something, but it's not you do not 100% compare the same things. That's usually the difficulty we see here. But the results is basically with the 3D model, I would say we have a very good geometric representation of the building, which is important, gives you much more information. So that would be a recommendation to include the 3D representation of the building in such a database. And it will come in INSPIRE in 2020, hopefully. So, and many European states already collect these 3D models. I know Poland, for example, has a national-wide 3D model. Finland, I was 2 weeks ago in Finland, they have plans to capture it. They have it for some cities, so I'm pretty sure that this is data you will have. But on semantic level, it's more difficult. Yeah? Building typology is one example. We talk about different building types, which is a problem because in the end, if we want to have kind of a unified or a similar methodology, we need to have the same category of buildings. And we currently don't have it. In theory, yes, the data model, yes, but in practice, the data is managed in a different typology. And then the mapping is difficult. Yeah? With the mapping, okay, it's possible, but you introduce a lot of uncertainty in the mapping process. This is one problem. And yeah, in details, also the different labels, the different numbers of labels is an issue. Yeah, so so there are, in detail, especially in the semantics, there are still open questions, I would say. Okay, with this, I would like to conclude and thank you for your attention. And okay, we have some more plans. We did a similar, or we are currently doing a similar study with Torino to have Italy data sets as well. So we learn with each country more details. Okay, thank you.
So now I will present you an effort which is currently ongoing within this energy pilot, and this is specifically related to a work that we are doing with Volker, because Volker spoke about the CityGML. So the Simstadt software, who was developed by you, by your team, has as input data CityGML, different levels of details, and then in the output is the estimated energy heating demand. But now let's see how to bridge the gap between CityGML and INSPIRE in the 3D world. I will give a short introduction, then a short recap of the source dataset, CityGML LOD1 and LOD2, and then I will show the 3 different mapping that we made between CityGML to INSPIRE Building 3D. The first one is taking as source data the LOD1 mapped to the INSPIRE 3D core, then the LOD2 mapped to the INSPIRE Building 3D core, and then the LOD2 mapped to the INSPIRE Building 3D extended, because as we will see, we show more opportunities. And then we share some conclusions. So everything has been done within this Elise Energy pilot. The use case, the first one was one which was pointed out, highlighted by Gemma in her presentation, which is dealing with an INSPIRE harmonization of energy performance certificate, but dealing with 2D data, just working on the semantics. Here is the second use case, comparative analysis of different methodologies and datasets for energy performance labeling of buildings. A first result was shown by Volker in the previous presentation, because it was applied in a sort of cross-border environment between the Netherlands and the north of Germany. But now, in this use case, we will see how this CityGML stuff can be mapped into INSPIRE schemas. The test areas are Zwolle and Essen. We will focus on the Essen dataset, and the context is the one that I introduced before. So again, the 4 level of details of the CityGML. There is the LOD0, which is the 2-dimensional, and then LOD1, LOD2 with the roof, and LOD3 with the openings, and LOD4 with the interiors. This is the Essen test area. This was the Zolle one, showed it before. And then this is the source dataset we started playing with, consisting of LOD1, almost 500 buildings. This is a snapshot of the UML data model of CityGML LOD1. And this is the second dataset, LOD2, in which you can see in the CityGML model that below there are some more complex aspects dealing with more complex geometries, and then we see that there are the possibilities to model the roof surface, wall surface, all parts of the boundary surface, which is attached to an association bounded by the building or the building part. So this was the starting point for us. Then the exercise that we made, LOD1 and LOD2 on your left-hand side, and in the center you see a picture taken from the INSPIRE building data specification, in which we see how the building theme, how the schemas belonging to the building theme of INSPIRE have been conceived. In terms of semantics, there is a base scheme and then an extended one. In terms of geometry, there is a 2D and then a 3D, so the combination of these schemas can lead to 2D base, 2D extended, 3D base, or 3D extended, or base or core, as you want to call it. So the exercise that we made for first to model LOD1 to core 3D, then the LOD2 again to the core 3D, and then the LOD2 to the extended one. This is again a simple a sample of the mapping table contained in the data specifications, in which you see that the attributes colored in green are those coming from core profiles. On the left we have the CityGML, and on the right the buildings INSPIRE attributes, both the core and the extended one, and the green colored are the core ones. So we see some good mapping, but some gap even. So how we started with that? The target schema is this one for we said the building core 3D, in which we see that the 3D geometry is mapped through the data type building geometry 3D LOD and below LOD 1 and 2, which inherits the properties of the data type building geometry 3D LOD. This is the mapping table that we used using the open source Hail Studio software to make the mapping between the CityGML on the left and the INSPIRE 3D building core on the right. And as you will see on the bottom, some attributes was not possible to map, like generic application property of city object, storage below ground, and address. This is the result of the transformation, in which you see on the left side the CityGML LOD1, and then on the right side a valid INSPIRE building 3D core GML transformed. Unfortunately, as far as I know, so I'm ready to learn from you, there are not yet tools to visualize properly the valid GML 3D coming from INSPIRE. There are many tools available for CityGML LOD, but still something is still missing here, as far as I know. But this is the proof that the transformation, the valid GML file obtained, proved that the exercise was made successfully. And of course, you cannot detect from the distance where you are, but there are some differences in how the geometries are provided. The same exercise was made for the LOD2, in which it was in the core, core building, 3D building core of INSPIRE. There is not yet the possibility to distinguish between the wall surface on the boundary surface. There is not any bounded by association, but we were able to map all the geometries contained in CityGML LOD2 into the native geometries of the core building INSPIRE. Using this, because there is a referencing mechanism that it was not possible to use in the core building 3D of INSPIRE. But then we used the possibility, we leveraged the possibilities to map exactly the geometries contained in the bounded by association of the CityGML into the solid geometries of the core model. And again, this is a result of the GML valid INSPIRE building 3D core obtained starting from a CityGML LOD2 dataset. But then we made a step further, which is to take benefit of the possibilities offered by the extended 3D schema of INSPIRE, because it contains, like the CityGML LOD2, the bounded by association with all the possibilities to map the components of this multi-surface composing the overall solid. But in that case, as you are well aware of, the starting point was that the draft schema needed to be fixed because it contained some errors. This was the starting point, and as you will see here, the main error to be fixed was this double inheritance of this feature type building, because when you transform this into an XSD, you have problems. You lose all the inherited attributes of one of the two inheritances. And then we solved here. This is the problem, and then we solved transforming one inheritance in one association. And then again, what we fixed also was this link, which is present in the extended, to the addresses, just renaming the name of the association from address to link to address, because it created some conflict in the namings. So first of all, we made, I think, this good achievement to obtain a valid buildings extended base schema, which now is fully usable. And then this is the extended 3.1, which needed to be a little bit modified in order to properly inherit the extended base schema, which is on the left. So we fixed these things, we created the correct schema to work with, and then we were able to make the mapping using, in this case, the same concept which is in the CityGML LOD2, also in the INSPIRE Building 3D Extended, thanks to the associations present in the Buildings 3D Extended fixed schemas to use the internal referencing of the single components of the multi-surface in the proper components of the model. And then again here, this is the starting point, the same CityGML LOD2 on the left, and then the valid INSPIRE Building 3D Extended GML on the right. Some conclusions of this work. So 3 different mapping between CityGML LOD1, LOD2, and INSPIRE Building 3D have been implemented. As I said, first taking the LOD1 to INSPIRE Building 3D Core, and then taking as a source the LOD2, we made two mapping, one to 3D Core, and the other one toward the 3D Extended. To do that, we fixed errors in the INSPIRE draft extended schemas and created the building extended base, which was missing at all in the draft repository, and then fixed also the extended 3D, which is now pointing to the right extended base schema. The mapping of CityGML LOD2 dataset to INSPIRE Building 3D Core or extended depends on the use case, because, for instance, according to what we are looking at, for instance, if we use the first mapping toward the LOD, toward the core, it's more efficient because the geometries are mapped more fast. But then in other cases, going to the extended can be more convenient. Reverse mapping from INSPIRE Building 3D to CityGML, which is easily doable, can improve interoperability of energy simulation software using CityGML input data, which was exactly what Volker was mentioning, because looking at the provision of harmonized 3D building data coming thanks to INSPIRE, with this reverse mapping, we can use the simulation software without any modification. And then also the harmonization of energy simulation output, which in terms of energy demand, because for the time being in the extended schema in terms of semantics, there is the label there. But then if we want to introduce additional attributes like the kilowatts per square meter per year in terms of energy demand, or other attributes that can come from other user requirements, it's easily doable, and we believe is a further step toward the interoperability of energy performance of buildings data. So I have shared what we have done. The work is still in progress, but I think that a good achievement has been done dealing with 3D building stuff. Thank you for your attention, and I suggest to move to the next presentation. Then if we have questions, we collect at the end. Thank you.
Yeah, my name is Koen de Witte. I'm working for the Flemish Environmental Agency. Our core business is water and air quality. I see a lot of links because we all spoke about EPCs, etc. It would be nice to have something like a WPC, where you have an indication of the water flows, for example, and the fact whether your water flows in your house are separated or not, and a lot of other things that could be measured as well. But anyway, we don't have a WPC at the moment, so we hope we'll get there someday. Yeah, we'll start with a brief overview of Flanders. Flanders, as you know, of the context we are working in. Flanders is a very densely populated area. So that means a lot of pollution, the main sources being, as you probably all know, industry, agriculture, and households. And when it comes to the purification of wastewaters, there's a lot of stakeholders involved. There's a broad division of powers, so every party, of course, has its own strategy, their own ambition, etc. So it may sound a bit negative, but anyway, there was also some data available with some of our more mature stakeholders, and some of these data were already digitized, so it was interesting. Very interesting to know was the point that, and it took quite an effort to get there, that most of the parties involved are convinced at the moment that working together is better than working alone. Within the premise, of course, that everybody has to have a benefit. Before I continue, I have to tell you that this is a non-technical presentation. It's something different than what the other speakers have told, but in the second part, we definitely have some more technical issues, so please don't run away and stay. Okay, of course we started with an ambition, and then our initial ambition was split up in different projects, to say so. For us, as being a government organization, it was of course very difficult, because this morning also you heard that from the point of view of technology, everything is possible at the moment. But when it comes to data and data availability and working together, that's something else. So that was very important for us as well, was the fact that it's not really a scientific thing or something else, but we needed to have some benefit for citizens, for the society. So in our case, of course, that is the purification of wastewater in the hope that we purify our surface waters. So we started with a feasibility study, and very important in that feasibility study is the fact that we focused on the expectations of the partners that were involved. The partners involved are mostly the regional authorities, but the local authorities as well, and we have a lot of private partners as well involved. So we tried to have an eye for the benefits of all partners involved, because if we wanted to convince the political level as well, it's not only the regional level that had to have benefits of this project, but the more parties involved and the more the people benefited from it, the more chances we had to gain sources to be able to do this project. So that's for us very important for to be able to succeed, is that it's not only a story of the Flemish Environment Agency, but it is a story for the rest of the stakeholders as well. They have to have benefits of this wastewater information system as well. Of course, we did some risk assessment, and some major risk were, of course, the fact that we had some local authorities, we had some private partners, so there was a big heterogeneity when it comes to maturity of data availability and IT. That was a big problem. Also, there was a big technical issue in the fact that we had to combine networks of a lot of different stakeholders, because they all work with their own data models, with their own systems, etc. So we had to combine it to make our own system for the whole of Flanders. And of course, we calculated the cost to have an idea what it all would cost. Of course, once you start, cost exceeds the first picture, but anyway. Then we agreed on the scope, and we got started. Yeah, I mentioned already that it's one of the things that is specific in our case is the fact that it's not only an intergovernmental collaboration, but there's also a lot of public and private, or a lot of private partners also involved. So the rest of my story will indicate as well that yeah, there were a lot of things, a lot of issues as well to be dealt with. The whole program was split up in different projects. The first ambition was to start with the sewage inventory, and then the next one would be making new databases, applications to support the expansion of the sewage network and the renovation, etc. A third ambition would be that the policy a bit further away and the geodata involved of the project that still had to be done in, let's say, 5 or 10 years should be integrated as well. And at least we would like, if possible, to integrate some geodata about asset management as well. So at the moment we are, I think, 1/3 of the way has already been done. There's still a long way to go. So before, of course, and it's a story you all know, I suppose, there was a lot of plans, most of them on paper, and being an environmental agency, I have to admit that there was still a lot of paperwork involved, and every year a forest had to be cut to make sure that we get all the information we needed. So was, but also with our stakeholders as well, a lot of paperwork was still involved. There was also a lot of information in the heads of some technical operators, etc. But luckily, we as VMM, we had a schematic database of the sewers for the whole of Flanders, and some of our partners as well had some information. Now, very important in our story is the fact that water doesn't stop at boundaries. So the water coming from your network may have a large impact on the network of the more downstream network. So that is very important. There was also one thing that everybody agreed on, knowing the network of your neighbor and knowing that is related and connected to your network is very important. So at the end, our ambition, of course, or we started, let me say that first, we started with taking a close look at the existing data transfers, at the afterlying processes, etc. We first tried to optimize those data transfers, and we tried to optimize the processes, and then we spoke about digitalization. So the first trying to keep the road as short as possible, and then try to go for digitalization. So this morning, in fact, this presentation should be an introduction to 2 other presentations, but the first one was this morning already, so I'm a bit late. For those of you who have heard that presentation, this was mentioned already there as well. We have about 308 local municipalities in Flanders. Flanders is not a very big region, so it means that a lot of small municipalities are involved. The numbers written here are a bit outdated, but about 50 of them do their own management, or they say they do so. Most of them don't do anything at all. I hope they're not here in this room, otherwise I might be shot. But most of them, luckily, have outsourced the management of their sewer network, and they've also outsourced the whole process of data inventory. So that is, for us, it was a big step forward as well, to know that there are partners involved with a certain maturity when it came to data availability and IT. So, of course, it wouldn't be very interesting to come with something totally new. So we looked around and we checked whether there were similar initiatives that we could use. So if we could step on the shoulders of others, we could reach higher. And very important for us, there was INSPIRE that allowed us to speak the same language, or at least to use some words that we could use in the communication, to say so. There was also the information model of cables and pipes. But for us that was not enough, because the final goal of an information model of cable and pipes is not the final goal of the implementation, to say, of the policy of wastewater treatment. So then we needed to extend the model, and as you see here on the slide, the core, of course, is the INSPIRE utility services data model. The first extension was the information model of cables and pipes, and then we added a lot of extra information to make sure that we got the information we needed. But very important in our story was most of the things we spoke about were already known. It wasn't something totally new. And very interesting as well was there was also already there were also some laws, to say so, obliging the local partners to deal with these problems. So somebody had gone the path we had to walk already, and that's always something interesting. So we made an application, and we made one central database which allowed all the stakeholders to upload their data. Then we combined those data from different partners, as I said so. And of course, there was a lot of data validation as well involved to assure the quality of our networks. Very important as well is that, and it was a request of all partners, that it wouldn't end with just making some agreements or gentlemen's agreements, but there had to be a contract as well to make sure that we would work in that our collaboration in the future would last. So it took quite a lot of effort to make a consensus about the content of the contract. We worked quite a lot in a lot of workshops. There were some sensitive issues. Most important one was how open should these data be? For us, it was quite obvious. Of course, it's open. There is European laws, there is national laws obliging us to be very open. But it may surprise you, even sewer data have a strategical and economical value. So our partners thought it was we had to give, or we had to deal with it in a different matter. Then the next step was the formalization. So first we spoke with the stakeholders. Then every stakeholder came with their legal representatives, and of course, if these people are involved, every word counts. So the number of sensitive issues multiplied at least with the factor 3. It was also a contract that needed to be expandable in further steps of our ambition. So the contract, the most important things here is that it's some kind of a commitment to do the maximum effort. But also we have a steering group that comes together every year where we discuss possible issues and look on the road ahead, to say so. Also the discussion about the property rights is given a lot of attention. The property rights are with the data, or the data owner is the stakeholder involved in this process. But there is and for all governments involved, there was an explicit reuse of every kind of information that was given or that was exchanged. But the further dissemination of the information to the greater public, that was a big issue. As I told you, even sewer data have a strategic and economical value. So that was something we had to make a big attachment, and we had to build our applications in a way that the more you are related to a certain area or a certain network, the more information you see. But the further you are away from it, the less information you are allowed to see. So yeah, that took quite a lot of effort. The next project, that was the sewage inventory. The next thing that is running at the moment is the planned expansion of our sewage network. Of course, it should be based on the sewer inventory. If you renovate your house, then it's very important that you start from a plan, from a decent as-is situation. So that was very important for us as well. We have two big investment programs to make sure that the regional policy concerning the purification of wastewaters is implemented, so local authorities can get a lot of money to do some local project, but they have to do it in a way that we agreed on, and there's also a data component involved. They have to, of course, make sure that the sewer inventory is okay. And in the context of this story, it's important to say that the exchange of project geodata information is on the same basis as the ones we are using in the sewer inventory. So we're building one central system. There are even more stakeholders involved, but the entire life cycle of the project is documented, and every stakeholder is able to do his interactions in the same, via the same application. So further use, and I come to the end of my presentation, is the fact that it should be nice to consult or do some consultation of this information in the field, first of all for professional users. It would be also nice to do some crowdsourcing for citizens. Yeah, we did some explorations on that, on both in the GeoSmart City project. That's still a work that is going on. But very nice as well is the fact that we are able, but we are still optimizing some things. We are able to trace to our sewage system and even more. But I won't tell you anything about this. This is the more interesting part of our presentation.
I will try to keep it short. On the one hand, Koen already told you, we have the sewer data. It's stored in one database, and it's based on INSPIRE data specifications. On the other part, we have the hydrography data. That's called the Flemish Hydrographic Atlas. It is owned by the Flanders Environment Agency, but it is managed by the agency and the provinces. They use an ArcMap toolbar for editing, but it's combined and stored in one dataset. Now, maybe you're thinking, why would you combine sewer data with hydrography data? But if I show you some pictures, I'm sure you all have seen them somewhere. And eventually, if the wastewater will be transported to the treatment plant, it will be treated and will enter the river network. But unfortunately, we're not happy about that, but there are also still some other points in the network where the sewer water will enter the river system directly or through discharge structures. To make it more clear, I had a picture. On the left, it's the dry weather situation where the sewer water will enter the sewer and will just be transported to the treatment plant. But if you have a combined sewer system, and it's heavy rains or the maximum capacity of the sewer is reached, the excess water is discharged into the river network. So that's something that's not a good thing for the environment, so we want to be able to detect that. So that's why we thought if we have both data sets, both network models, and we make an algorithm that can trace on both models, we plug the algorithm into our own tool, which visualizes the data and gives an interface to the tracing algorithm. Then everybody in the sewer sector can use the tracing tool to trace the wastewater through the sewer network and the hydrography network. Our tracing tool has different options. You can trace upstream and downstream. You can trace at dry weather, but also rainy weather when we assume that all overflow structures are active. You can choose to not include or include the hydrography network, and there are some extra filtering options based on the attributes of the data model. And also search distances can be entered. So why would we need a tracing model or tracing algorithm? Well, this is one example. If you know, for example, there is a fire in a chemical factory, the excess water that is used by the firefighters will enter the sewer network and the pollutants can possibly end up in the river network. So if you see what the tracing tool will do is if you click at a factory, it will calculate the route the wastewater will take. In red, the route of the sewer system that leads to the treatment plant in the north. But if you look closely, you also see that there is an overflow structure. So if the maximum capacity of the sewer is reached, that will become active, and the wastewater will flow through the river system into the recreational water. And that's something, of course, we want to avoid. So by giving this information, by just clicking and tracing the wastewater, we hope that a decision maker can do something about it. For example, he or she can decide to shut down the overflow and force the water to the treatment plant where it can be evacuated, and the recreational water has no damage. So that's one example, but what we actually just want to do is combine information to quickly get an overview, to help first responders and authorities to get an overview of a precarious situation, but also, for example, to help sewer managers to better understand their part in a bigger network, or help with planning and renovation by using the different filtering options. But then we were thinking, yeah, we use an INSPIRE model. Maybe we can use the algorithm on other networks or other countries on other INSPIRE data. And so we thought if we have those data sets, for example, from the Netherlands, it's easy, we speak the same language, so that helps always. Then if you make the tool that we developed, if you can make it open source and standardized, then everyone could use it, and the tracing results will be available for more than one party, and the tool would be more easily plugged in different applications. So that's the idea we are working on the Interact Northwest Europe Be Good project. It's about open data for a smarter society, and we will be trying to combine or to use the algorithm and to make it open source with our own sewer data, but also with data from the Netherlands that also have an INSPIRE data set of utility. So we hope if we can prove that it works for those both data sets, that it also can work for others, and it can be used for different alternatives. So if you want to know more or follow up what we will be doing in the project or one of the other challenges, you can always visit the website. And that was it.